A conveyor is a mechanical system that is used to move materials, packages, or products from one location to another. Conveyors are commonly used in industrial settings, in warehouses and logistics operations, and in many other types of facilities. There are several types of conveyors, including belt conveyors, roller conveyors, chain conveyors, and screw conveyors. Each type of conveyor is designed to move materials in a specific way, and is suitable for different types of materials and applications. In order to properly design a conveyor system, several calculations must be performed. These calculations include determining the necessary belt width and speed, calculating the required motor power, and determining the maximum load capacity of the conveyor. Other calculations that may be necessary include determining the amount of tension required to keep the belt properly aligned, and calculating the acceleration and deceleration of the conveyor. Belt conveyor calculation. 1. Belt width. 2. Belt speed. 3. Motor power. 4. Bulk density of conveyed material. 5. Trough angle. 6. Deck type. 7. Belt tension. 8. Idler spacing. 9. Load capacity. Roller conveyor. 1. Speed. 2. Load per linear meter. 3. Drive and idler roller diameter. 4. Bearing life. 5. Material. Screw conveyor. 1. Speed. 2. Capacity. 3. Power requirement. 4. Density of material. 5. Inclination angle. 6. Size of flights. 7. Type of material. Chain conveyor. 1. Speed. 2. Capacity. 3. Power requirement. 4. Density of material. 5. Inclination angle. Size of flights. 7. Type of material. 8. Chain pulling load. These are just a few examples of the types of calculations that may be required when designing a conveyor system, and actual calculations will depend on the specific requirements of the application. Here are several formulas that are commonly used in the design and calculation of conveyor systems. Some of the most important formulas include belt speed. This formula is used to calculate the speed of the belt in meters per second. The formula is V equals dt, where V is the belt speed, d is the diameter of the drive pulley, and T is the belt tension. Motor power. The power required to drive a conveyor belt is given by the formula P equals Txv, where P is the power required, T is the torque required to drive the conveyor, and V is the belt speed. Conveyor capacity. The capacity of a conveyor system can be calculated using the formula C equals AXV, where C is the conveyor capacity, A is the cross-sectional area of the material on the belt, and V is the belt speed. Trough angle. The trough angle of a conveyor is the angle between the horizontal and the bottom of the conveyor. The formula to calculate the trough angle is alpha equals atom 2HL. Load carrying capacity. The load carrying capacity of a conveyor can be calculated using the formula LC equals belt width belt strength, belt width plus 2H tan, inclination angle. Screw conveyor. The capacity of a screw conveyor can be calculated using the formula Q equals AX dx NX0, 1118 by 60, where Q is the capacity in cubic feet per hour, A is the cross-sectional area of the screw, D is the screw diameter, and N is the revolutions per minute of the screw. These are some of the most important formulas used in conveyor design and calculations. However, it is not limited to that, and the actual calculations will depend on the specific requirements of the application.